question: what keeps planets orbiting stars? What keeps stars swirling together in galaxies? And what prevents galaxies themselves from flying apart into the void? Hello and welcome to Astrobitica, your home for space news and cosmic storytelling. Here we turn black holes, exoplanets, and the mysteries of the universe into something you can actually follow and maybe even feel a little awe along the way. Before we dive in, make sure you subscribe and tap the notification bell because the cosmos never stops moving and you don't want to miss the next chapter of its story. The answer is an invisible hand that sculpts the very shape of the cosmos. That hand is gravity. Gravity is, at its core, the attraction between any two masses. The more massive the objects and the closer they are, the stronger the pull. In the late 1600s, Isaac Newton was the first to describe this force with mathematics. You've heard the story, the apple falling from the tree. But Newton realized that the same force pulling that apple to the ground also keeps the moon suspended in orbit around Earth. With Newton's laws, the universe suddenly became predictable. We could calculate the path of planets, predict eclipses, and centuries later launch rockets, land spacecraft, and even walk on the moon. But there were still mysteries Newton's equations couldn't solve. Fast forward to 1915. Albert Einstein shattered the old picture with his theory of general relativity. Einstein showed that gravity isn't a simple tug of war between masses. It's the very warping of space and time itself. Imagine space as a rubber sheet. Place a heavy ball in the center. That's a planet or star. Now roll smaller balls nearby. They don't fall because they're pulled into the usual sense. They roll inward because the sheet itself is curved. That's how massive objects bend space-time. This radical view explained things Newton never could. For instance, during the solar eclipse of 1919, astronomers observed starlight bending around the sun, just as Einstein predicted. It was one of the most dramatic confirmations in the history of science. Now, think of the moon. It doesn't crash into Earth because it's moving sideways quickly enough to continually miss us. It is in a constant state of free fall, orbiting endlessly around our planet. Earth does the same thing around the sun, and the sun, in turn, circles within the Milky Way. Gravity produces the structure, while orbital motion keeps everything from collapsing inward. But gravity doesn't always play nice. When massive stars exhaust their fuel, they collapse inward, sometimes forming black holes. These are regions where gravity is so intense that not even light can escape. At the edge, the event horizon, space-time is curved to an unimaginable degree. Clocks slow, time itself behaves differently. Einstein's equations also predicted something even stranger: gravitational waves, ripples in the fabric of space-time itself, caused by massive objects accelerating. For 100 years, they remained a theory. Then, in 2015, detectors at LIGO picked up a faint chirp. Two black holes had merged more than 1 billion light years away, and their collisions shook space-time itself. That single signal opened an entirely new way of observing the universe. Why does it matter? Without gravity, there would be no stars, no planets, no galaxies, just a lonely scattering of particles drifting forever. Gravity gathers clouds of gas and forms them into stars. It lights those stars, guides their planets, and sculpts galaxies, binds them into vast cosmic webs stretching across the universe. Even today, it wrestles with dark energy in a cosmic tug of war, expansion pulling outward, gravity pulling inward, deciding the fate of the cosmos. And gravity isn't just out there shaping galaxies. It's right here. Every time you drop a pin, leap into the air, or simply walk across the ground, you're connected to the very same force that bends light around stars and merges black holes. You are feeling the universe itself right now. So the next time you look up at the night sky, remember, what holds that grand cosmic dance together? From the moon's gentle orbit to the tearing extremes of a black hole, it's the same force that holds you to the earth beneath your feet. If you learned something today, give this video a thumbs up, subscribe to Astrobitica, and tap the bell so you never miss another journey through the cosmos. Until then, keep looking up and stay curious.